Um, right. So I'm hopefully live again with really, really bad quality. But uh, yeah, hello people. Uh, Welcome back. Uh, Chat's disabled for the live stream for some reason. That's okay. Um, Hi. Oh, there you go. It works. So, welcome back. Remember, we were lead coding. My OBS crashed my computer. Well, that is a sentence I get to say. Well, that is a sentence I get to say daily. Miley, my OBS setup crashed my computer. Right. So let me actually set that to balanced performance. Hopefully that changes something. Most probably won't. Yeah. I This is actually the snap version of OBS that I'm running right now. Just I just had, as you can see, I installed OBS there. It's a third party source, but I really like what they have done. So yeah, I was using the official one from the PPA before, and they just kept crashing for some reason. I had to do a lot of workarounds. The one with the flat pack, uh, for some reason, it was resetting its config every time I configured it. So I was like, okay, just I'll just install this Snapback one, right? Um, yeah, recover that, recover that. Right. So this is where we left it at, and I identified a crucial mistake. We forgot to reverse these things. Right. So we are not adding this. We are in fact adding this. Right. So we are in fact not adding this. We are adding this. And I don't know how that was right, how it passed the test case. I have no idea, but see for some reason it passes the test case. I'll just leave in the print statement. I mean, it's not harming anyone. It will probably also help us debug. Oh, accepted the solution. That's cool. So I can paste that in happily and comment that. So the text editor here, as you're seeing here, is a text editor called Micro, which it's sort of aimed at beginners and pros alike. I certainly don't consider myself in any of those categories, but it basically offers a almost notepad-like experience, which I really appreciate. I mean, to me, when I'm using Micro, it's like I'm using Notepad with a little bit of syntax highlighting. That's it. So it's really basic. It keeps me super focused. And if you're like, this provides the same thing as the uh, lead code one does, you're right. But I mean, I like it. So, Sudoku solver. I've been looking into creating a Sudoku solver since a really long time. I have to do that someday. Uh, Trapping rainwater. Combination some fountain say. What does fountain say? And why have I already tried it before? Okay, so there are two threes, three twos. Okay, 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 okay. This seems fun. I want to add into this. Then this is the base case, right? So NS4. Uh, C11. What? Cow say 1 is 1. Cow say n is the way you would see the digit from which is then converted into split it into the minimal number of substrings such that each substring contains one unique digit. Okay. Okay. Interesting. N is 4. N is 4, right? So the base case is 2. Mm, 1, 1, 2, 1. Say 2, 1. Say 1, 1, 1. Say 1, 1 is 2, 1. Say 2, 1 is. Say 2, 1 is 2, 1 and 1, 1 is 1, 2. Ah, oh, so that's actually quite interesting. Oh, I'm sorry. Do I have constancy? I do not have constancy. So micro constancy dot py. Right. That's actually pretty cool. So if I go solution is well the solution and then we can print solution dot count and say 4. Yeah, I guess this is what we have to do. So count and say really simple. Uh, we have to obviously use recursion, right? So if n is 1, right, return 1. Uh, right. Mm, right. Else, oh, this is start of else. I don't need this. Right. Let's actually write this out on paper. So by paper, I mean like a comment canvas, so I know what's going on. So 1 becomes 1, 1. 1, 1, 1, 1, 1, 1 becomes, so this becomes 2, 1. And 2, 1 becomes 1, 2, 1, 1, which in turn this becomes 1, 1, 1, 2, and 2, 1, which in turn this becomes 3, 1, 2, 2, 1. So that is how the progression goes. Right. Quite quite a interesting progression we have here. Right. Um, actually, let's actually look to see if there are any patterns. So we obviously need to convert this into a string. There's no other way we can do it. So one is a int, curiously. Weird. But it returns a string. You know, that's interesting. Mm, there was something curious being said about is from count and say n minus 1 is the way you would say the digit from n minus 1. So you would say the digit for 3, where let's just use this bits of information. Uh, and there's no guarantee that it'll be in the correct order. Okay, so How about we just say it and we take an empty array and like for I in wouldn't it be better if I sort of do this instead, like a hash map? What do I name this? Like dict? No, the dict already exists. Uh, like nums is an empty dictionary, and we can do the classic way where you split, but we will lose the order on doing this, so we don't want that. How about we have an empty string for the result, right? And for that empty string, we can probably do something. Uh, I'm sorry. Uh, for that empty string, we can do something. Yes, yes. So if n is 1, we return 1. But right, if n is 1, you return 1. Else, its count say of n minus 1. Yeah, okay, that's what we did in a more programmatic way. Uh, is there any way we can use recursion? Because this does seem like a recursive thing to me. Mm, like, I mean, if n is 1, then we return 1. Actually, I think I should be more optimal about this. Set up a timer of like an hour, 45. If I'm not able to solve it by then, I'm looking up the solution. Uh, huh. Like, I mean, what other way do we have to get that? You know what? Forget about the recursion thing. Let's do this in for loops. Make it more imperative. Forget about declarative for now. Right. So, like I is an integer for I in range of n. Right. So we get 0, 1, 2, 3. Hmm. Result is that. If actually let that thing be interesting. So for I in range n, mm, there has to be actually something that counts also. I just can't keep redirecting there. Right. Result appends to that, and that's all willy-nilly. So the result, yeah, for now, like I can just say nums list is a list of str of n, y and o. Yeah, str of n. Wait, that makes no sense. No, that makes no sense at all. N is just for like the number of times we want that to happen. So yeah, we don't need that. The result starts with 1, and the nums list, yeah, it can be there for now. Like let's just declare a variable there for now. Result append get counts. Let's have a function that has a num that is an int, and this once again returns a string. Right. Now this would start to make sense. Actually, let's just have that string. That's easier. Right. Get counts. We have nums is list of num. Uh-huh. How about we have a nums list, which is an empty list. Right. Mm, and like for I in nums, for I in nums, if I in nums list, then nums list uh, find index of something, but no, that would make no sense again. Or I0 while I is less than the length of nums minus. It's okay. Mm, while uh, like the target is nums of I, while nums of I equal to tar, I plus equal to 1, that happened. And counter variable called I'm sorry, let's also have a counter variable called num. We'll track the uh, appearance, no, times, like we have something like that. um, Times plus equal to 1, I plus equal to 1, right? And like after all of that, after all of the I plus equal to 1, hmm, we can just say nums list dot append times plus uh, let's just be safe, times of I plus nums of I plus the target, because that will be misplaced, right? So how about you just for now print gets counts of something like 1211, and then I'll be impressed. Delete CD medium. Where is that? Where is that? Mm, counting say. There you go. So Python 3 count and say. Counts is not defined. Self-dot counts takes with one positional argument. Two argument. Oh, yeah. Mm-hmm. No, nums of I is still out of its stage. Where the oh, in the while. In the while loop? That's weird. 0, 1, 2, and 3. Right. Mm, yeah, nums should not go there in the first place. Like 0 is fine, 1 is fine, 3. What's the problem with 3? Like friends num of 3. 1, 1, 1, 1, 1. Oh, right. Mm, mhm, mm. Like if I is less than length of nums minus only then wait, that makes no sense. Now if I is less than the length of nums minus 1, only then do this. Else just break. No, 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 no. How about you just print I for me now? 0, 1, 2. There is never a trait. There's never a 3. Why the hell is that? Like, can you print out that for me? Uh, like 0, 1, 1, 1 to 2. 2? What? No, 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 wait, wait. Confusion. Okay, so 1, 1 to 2. 1, 1, 1, 1. But that makes no sense. 1, 1. And also print out the times. What? Am I not adding 1? 1, 1, 1. The times is 1. Shush. 1, 1, 1, 1, 1. So is that what I get? 1, 1, 1. 1, 1, 1, 2, 1, 1. No, I should get a 2, 1. That's where I was doing the mistake. Actually, what's return the nums list? 2, 1, 2, 2, 3, 1. 2, 1. Wait, what? Hmm, if it's just 1. Yeah, like why are they even adding up? Like they should not add up. Uh, I don't think that is how it works. Is that how it works? I don't think so. Because if we have that, uh, we have like this goes into the loop. The target is one. The target is one, times is one, right? While one is equal to the target. Yeah, yeah, times can safely be zero there. One, 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 two, two, one. There you go. Yeah, that's perfect. So, okay, so we found a way to return the exact one. Actually, let's test it with that as well. Oops, I forgot. Terminal is not as friendly as my text editor. Right, I should get 31221. 31221. No, 3122. You'd see one again. Uh, uh, that's out of range. If zero comes in, three comes in. Oh, right. That, yeah, next three comes in. Good. So, um, that's why that becomes three. Cool. Uh, then that becomes two, 3122. So one never even appears. If I is less than length of nums, yeah, then what is the problem? Like till where is one able to come? 0, 5. From where did 5 even come from? Like, oh, so it's fundamentally wrong how we are approaching it. That's that's totally wrong how we are approaching it. Oh, that's not how you do it. Uh, no. So we don't want to stray too far. That's a never-ending loop. It never ends because that becomes a never-ending loop because same thing can never appear. But does this have 0, 1, 2, 3? 0, 1, 2, 3, 4, 5? Then yes, that does have a 5. Like, what? Oh, this I plus 1 is what? If 5 is less than or equal to, still you're not happy. You're not correct. Remember that. I plus equal to 1. Yeah. Now let's again study the error. So this is our goal. The length is 6, obviously. The last index would be 5. So while I is less than length of 5, so I will become 5 at one case or the other. Right. How about, no, but that would be too late. That would be too late because this function call recurses to the while loop. And we once that happens, all of this is out of our control. Right. We cannot really do anything once that happens. We want to be able to do something before that happens, such that uh, we want that. Okay, this is like the most basic amount of Python. Why am I not able to do this? Uh, how do I do that? Uh, or no, I can't do that. No, no, no. No? Uh, is there any way I cannot add I plus plus because I in this case is 5. How about I say if I is equal to the length of nums, then just break. Like, is that even coming into this? No, it's not even considering that. Uh, you know what? Leave that. That's fine and nilly dally. 5 and 110. 5 and 110. 5 and 111. About dropping that up in there. No, that's still a problem. Fine, fine, fine. Can you print an I here? Yep, it is going into that loop. That's our toxic loop. Stay away from toxicity. Okay, that becomes a never ending loop because I never really reaches break. And but if I do that, uh, mm, if I comes to that, how about you perform the operation yourself? Like I'm handing some responsibility to you. Like there you go. Wait, what? Why the double one? Nah. Why the extra one there? Oh wait, yeah, I was the one who's mistake. One more. So there we go. I guess we have effectively solved it because we at least get them now. So now I guess all I have to do is like I don't even need that. Like, all I can do is like for I in range of n, Um, Actually, yeah, I needed that nums list. Mm, yeah, so we need to get the first one. Nums dot list. No, nums list dot append get counts self dot get counts of the result of no, the current. I guess calling that a current is a better word. Current, and then current in turn becomes actually like temp is that once we pass temp in, current becomes temp, and then we just return the nums list. One, where is that? For ns4, we, oh, so just doing that helps. There we go. What happens when I say that n is 1? We are returning an empty list, which is bad. Mm, is that how you do it? Is that how you do it? That's a problem. Is that how you do it? No, that's not how you do it. Let's find some. That's how you do it. So I do that. Oh, it's still a 0. Uh, how about a simple base condition? What's it? Say for everyone. So if n is 1, return correct. How about that? There you go. Now if n is, let's say, 1, there you go. I don't think there are any other test cases. So, and it is not above 30. So this most likely will not get into any trouble, right? Hopefully when I run that, uh, it actually passes. NS4, oh, return the last one. Where is that? How you return the last one? I forgot. No, that's not how you return the last one. Python, Python, Python. Mm, mm, return last element in list. Oh, that's just -1. That's as simple as that. Oh, well, now I filled up. Uh, so hopefully, yeah, that works. Let's submit that and really hope for the best. Oh, and that was so slow. How did most people do it? You're kidding me. It was that easy all along. It was really this easy. Oh yeah, like that's we can probably optimize this, right? we were pretty close to the answer, like pretty close. Regardless, we can call this a job well done, and say salt can be better optimized. Right, we can remove all of the while loops and stuff like that. Maybe if I remember more Python, I'll be able to do it. But wow, that was a huge pending, and I was able to do it. So, la la, I guess. Hmm. Combination sum. This was also a very big pending for me. Mm, so, given an array of distinct integers candidates and a target integer target. Return a list of all unique combination of candidates where the chosen sum to target. You may return the combinations in any order. Maybe chosen in an unlimited number, two combinations of the frequency. Hmm. So isn't this just two sum? Yeah, this is the amount of confidence a guy who doesn't know two sum. Anyways, so this is two, two, three, five. So I can use this how many ever times, right? First of all, let's do the general stuff that really helps me brainstorm. Oh, I have already done myself something here. I don't even remember doing it. Python 3 combination sum 7. Yeah. How about we move that to, yeah, we do that and oops, not that micro combination sum. There you go. That's not a list. That's a list. Oh, it's a list of a list. Cool. So let me actually print out the solution. Solution. Solution of list of candidates of 2 comma 2 comma 3, and the target, which is 7. There you go. So I guess we have to solve this. Hmm. Uh, right. So interesting. I don't know if I'll even have the patience for this. Like I thought like, well, so I'll do 2 leet code problems a day. I'm pretty much done with that. But and we still had 13 minutes remaining on the clock from the last one. I'm sure at this point it got scared. 45 minutes. There. And yeah, let's actually do some time pass for some time, I guess. So oh, hey, I actually forgot to tell you guys. So daily.dev has this new feature of search that I've been trying this out basically since like uh, a month at this point, and I'm really loving it. Right. So the combination sum of the candidates. So we have a target of let's say 7, and if we recursively subtract, no, wait, the docstring playground again. So let's say we have a target of 7. Subtract 2 from that, we get 5. The first element. Then check if any of the remaining things will be able to complete it. So we again do a minus 2. 3 minus 3 would be a 0. But here's the problem. Oh, I'm sorry. 3, 2, comma, 2, comma, 3, comma, 6, comma, 7. Right. So for each element, if I do a 7 minus 2, which is a 5, none of them add up to 5. So that's eliminated. 7 minus 3 don't add up either. But 7 minus 2 is 5. And then 5 minus 2 again adds up to, that's hella complicated. Uh, I don't want to get into this right now. So, sorry, debating. So I was just telling you guys about Dev's new AI extension thing. So you can ask it any question and it returns the latest answer. It's like a wrapper around a few AIs, and I'm really liking it. So if I ask, for example, suggest some cheat code problems for beginners, and yeah, it lists out the sources, and I have like 5 API keys. I have 5 invites. If you want them, just leave it down in the comment and I'll give it to you. So yeah, this is pretty good. This is what it does. It is an awesome piece of utility, and yeah, I've been really liking it. And if you would do, I have like 5 access keys. I think I've probably given like 2 out already. So you have 3 more. So just let me know if you want it. Anyways, so it's a combination song. This ain't happening. No. Mm, power. This is interesting. This looks interesting. So implement power of n, which calculates x raised to the nth power. That's simple. Wonder why it's in medium, but it says implement, not use. Uh, okay, so it takes me to c++.com. Study power. Oh, I get it. I get it. Just have to implement that. Let's actually with this remove combination sum and combination sum dot all to combination sum. Like that's at least an attempt. Pi power of start pi. Hmm. Really interesting. So solution is a new solution object, and like I should print out solution dot my pow of 2 and 10, 2.0 and 10. Right. So that's cool. So first things first, I guess there are only 3 base conditions. Uh, like if n is 0, return 1. Right. Mm, else if n is less than 1, then So, like if n is less than 1, then let's actually have like a result thing here. Result is 0 or result is 1 to be better. Just return the result. Right. Uh, so result would then docstring time. Let's actually work this out. Mm, so if it is 2 to the power of minus 4, how do you do it? It's 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2. Right. But how do you know it is 1 by 2? Is it because of the denominator? What happens if the denominator is by 2 there? But n is always an integer, so we can at least rest assured there. So you can just directly do that. So if n is less than 1, for I in the range of n, result is multiplied with 1 by with 1 divided by x n times. Right. And if n is greater than 1, for I in range n, the result is multiplied x times. Right. Same thing. But then we finally return result. My power. What's that called? Power x. That works. Cool. 2 and minus 4. That should be 1 by 16. What? It's not 0 though. Print I. Oh, oh, oops. There we go. What? 1 and 2. Okay, after the each thing, print the result. But it only runs 1. Print N. Okay. Click print I. That's weird. Oh, oh, oh. Right. How do I do that? Convert to positive. How do I convert to positive? Oh, oh, so absolute. Cool. ABS. ABS. There you go. There you go. Hopefully now we are happy. That's more like it. Wait, how do you need it? Oh, you need it like that. So that's cool. Yeah. This is our function. Nothing too fancy. Mm, on that. Then hopefully we will accept all the cases. But there are companies asking this question. I think my hubris is about to be challenged a lot. Wrong answer. Oh, oh, oh. That's. Oh, I have no base condition as to what happens else if n is actually 1. Then we just return x. right? I don't have that condition in the thing at all. That's, yeah, that's a slight oversight. Yeah, but I can see that increasing the complexity. You know what? If things get out of hand, I'm using Rust for this. Yeah, time limit exceeded. I'm going to try use Rust for this, or even Go for that matter. But I guess Rust. Uh, so yeah, I don't know why I'm using Rust, but I mean I know why I'm using Rust. Rust is fast. Uh, oh, .rs. There you go. We put that in. Okay, so this is what I like. It has basic syntax highlighting, just up my alley. But here's the problem. I have I need an IDE to code in Rust. That's really embarrassing, but that's okay. Yeah, what happened to you? Yeah, I mean that's okay, right? You don't need a like a solution is solution and solution dot my right. Oh, without a workspace, I guess even that is useless. So might as well just do that. So I need one though. Solution is solution, and then I go solution dot my power like 2.0 and 4. And here I can like just go be like println hello world. Those and after each this thing rust c expected item. Okay, so that's a const. Um, solution. I mean, I'm not that well versed in this. Oh, why was I accessing it like that? Huh? Wait, what? That's so weird. Maybe I don't use Rust. I Yeah, I never actually worked with Rust without sort of uh, how do I put that? Uh, workspace basically. Yeah, I always used it with a workspace. Come to realize. So package main, I guess, and then function uh, fmt dot println hello world. Yeah, yeah. So it's just simpler. Like it won't kill me. Go build. Oh, there you go. Oh, hello world. That's awesome. Oh, I guess I can now go do whatever I want in this. Okay. So first things first, I need to translate my Python implementation into Go. Okay. Let's actually take the boilerplate. That's all you need. Mhm. Now, Python 3. Uh, I just call you at this point, like my power of 2.0 and 4. Oh, you actually want me to return something? So fine. FMT dot println, right? Huh, weird. Missing return. Oh, for this you have a support. Okay, so really basic operation. We just do result is 1. Actually, I don't think I think I need to. If n is 0, you return the result. Or okay, if n is 0. No, I guess 0 neither. Else if n is 1, you return x itself. Mm, or like else if n is greater than 1, mm, range in Go. Is there even a range in Go? Oh, so we have a slice. No, no, like to implement for I in range. I. Oh, you okay? You directly use a for loop. Yeah, there's no other option. Right. So for I is equal to 0. Okay, put that. I is less than the I is yes, I should be less than n. I is less than n. I plus plus. And then you do a result is plus equal to sorry into equal to into equal to x, and then you return result. And if I ever have to do that, I go to go slash medium. I go build my path dot go syntax error 10 syntax error expected unexpected undefined result undefined result. Okay, so let oh no, you just do that. Um, okay, 1.0. There you go. 16, which is right. Okay, so else if n is less than 1 for I is 0, I is greater than n and I plus plus, minus minus. I mean, that's a fun way of doing it. 1 by x. So minus 2. Yeah, this is fun. So this is all I'll be needing. So if I go to go, save that and run it and wait for the Go binary to compile it. Yeah, I guess that seemed bit faster. But I guess unless I really optimize the algorithm, no. Yeah, it will still struggle. Mm, I guess there should not be a for loop at all. Mm, because for loop is the problem. Mm, mm, no, I didn't realize it's going to be this weird of a problems, and is basically like this range. Even a very good language like Go would take hell of a lot of time, but that still results to one. So I guess instead of writing it in Go, I should focus on uh, sort of improving the Python itself. So let's put that. Let's go to have it in Go. I know how to write it, but oh my god, there you go. Right. Yes, I guess there is somehow I need to remove the for loop and the range. Something that would perform almost a direct calculation. Like, mm, right, let's see. 2 to the power of 4 is 16. Right. So log 16 to base 2 is what? 4. Right. Right. No, I don't think I can do anything with that piece of information. I just can't go on adding stuff up until. No, no, that's not worth it. Has to be some other way. Mm, but is there any way I can optimize it? No, it has to be multiplication. Uh, oh, my time limit is gone stale. Give myself like 20 more minutes for this. Mm, I mean, it's such a simple implementation. What could be wrong with this? Like instead of it repeating, even a while loop would repeat the same number of times. There's no real benefit to it. There's no real benefit to it. Uh, mm, Powers. How do I implement powers? Mm, okay, that would optimize it a bit, just a teeny bit. I guess we are fighting for the teenies at this point. Uh, Use that test case as well. Yeah, I'm sure the time limit will still exceed this. There is just no way. Yeah, there is no way. Even fails for that. Forget about the other things. Yeah, time limit exceeded. Okay, I think we should finally look at the solution. Or wait, or wait. I don't think there's a need to look at the solution. I think recursion has given us the perfect. Right. LF, um, return my pow, or like return my power with no wait. Let the case like 2 and 4. Right. So the first enter is greater than 1. So they'll always be stuck here. Right. So then here, if we return x into my power of x minus 1, n minus 1, x comma n minus 1, then what happens? So that becomes x into my power of x again. But this time it becomes an x again. Right. Uh, right. So that's it. We just return that. No context required. Actually, let's put in like a small thing. Uh, like if n is less than 1, x is 1 by x. How about that? Does that work? My power is not defined. No, right. Self dot my. Okay, weird. Oh, there you go. That works. Maximum number of lines repeated. Yeah, I guess it's just better to do this way. Self dot my power 1 by x minus n minus 1. It's the same concept. Uh, oh wait, like n n does reach 0, so mm, only then if LF is n minus. No, no. How about that? 1 by x still returns, but let's n plus 1. Float and non-type earth. Uh, uh, Float and non-type. Weird. So And like n is minus 2 here. Right. So it goes there. Minus 2 all the way. 12 dot my power of 1 by x and n plus 1. Right. But then like no, one more thing. Lf n equal to 1. Just return it. Wait. Mm, we don't need to add that. This is problems are there. So, wait, am I even live? Oh, okay. So I'm live. Anyways, like it's 1 by x. And the only real problem we are getting is unsupported operand types for float and none type. So at some point or the other, that's returning a none type. I just need to identify which case. Uh, mm, mm, this is all easy peasy. This, I guess, is the problem. Mm, and if n is greater than 1, or else if all hope is lost, just return 1. You know what? Not none type, but why is it none type in the first place? It's not none type. Mm, what is less than 0? No? 9, 12. Huh. How about before we do all of this, we just print n minus 3, minus 2, minus 1, 0. Minus 3 uh, going to minus 3, minus 1 into 0. Going to 0. Going to 0. That's finally. That is literally so stupid. 0.5. What? Wrong answer? What? Mm, that's absolutely the wrong answer. Mm, mm, 3, 2, 1, 0. Mm, yeah, I mean, yeah, that actually makes sense. But Oh, 1 divided by x. No, no, no. I guess putting it in brackets. No. Uh, I don't think that does anything. What's really happening here? So minus 3, 1 by 2 into 1 by 2 minus 2. That's 1 by 2 into 1 by 2. Wait, 1 by 2 into 1 by 2 again. 2 minus 1. So it's 1 by 2. And, uh, 3 went 3, 2 went 2. 0, 0, 0 went. There's no way that there's a chance for 0 point. I think there's not even a chance. Uh, mm, it's 3 went 2. 0 went 0 point 5, 0 went 0, 1, 0, 0, 0. No, 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 no. It's not how you do that. 0.5. That's so weird. What is 1 by x? We do that.